6.4 Trigonometric functions of any angle. What we're going to cover are a couple of the basic trig functions. These are the popular ones. The first one, a 30, 60, 90 right triangle. To find the sine of 30 degrees, how do you find the sine of something? Opposite over hypotenuse. So here's 30. What's the opposite? 1. What's the hypotenuse? 2. The sine of 30 is 1/2. If you put in sine of 30 in your calculator, you get 1/2, as long as your calculator's in degrees. Cosine of 30 is adjacent over hypotenuse, which is the square root of 3 over 2. The tangent of 30 is opposite over adjacent. Now this one you have 1 over the square root of 3. We don't leave radicals in denominators. So I technically multiply both by the square root of 3. So I have square root of 3 over 3. Last time you probably saw that was geometry. Now I have the sine of 45, the cosine of 45, tangent of 45. This is a 45-45 right triangle. It's an isosceles right triangle. So to find the sine of 45, 1 over square root of 2, which is the square root of 2 over 2. The cosine of 45 is also 1 over the square root of 2, which is square root of 2 over 2. And tangent is 1 over 1, which is 1. Now we already did the 30-degree one, now it's the 60-degree one. All I did was took the first one and flipped it around. If you also notice, I have this p, 1 comma square root of 3. That's the legs. 1 is the x value, the square root of 3 is your y value. So for sine, it's opposite over hypotenuse, square root of 3 over 2. For cosine, it's 1/2. For tangent, it's the square root of 3 over 1, which is just square root of 3. We're going to find the exact angles or values for sine of 315, cosine of 315, tangent of 3. I know I could go in a calculator and just go tangent of 315. All right. Standard position, you have this here, and it rotates around 315 degrees. But what did it create here? What's the coterminal angle? It's not 45, it's negative 45. This is 315, so that's negative 45. I need the sine of 45, the cosine of 45, the tangent of 45. So I'm going to look here. What's that? Correct. So I'm going to put, but all I have to do is look here. What's the sine then of 315? The sine is going to be, it's going to be negative square root of 2 over 2. The cosine of 315 is going to be negative square root of 2 over 2. And the tangent is going to be negative 1. Just to show you in the calculator. First thing I'm going to make sure this is in degree. Sine of 315. I get negative 0.707, which if you look on the sideboard, 0.707 is square root of 2 over 2. Do the cosine of 315.
Why is that a negative?
There's something about why is it negative? Because the sign in this one is negative. This one's actually positive. If you go back to the first day of notes, where I said in the first quadrant it's this comma this, the sign deals with this one right here, up and down. That's the negative. That would have been positive, so that one's positive. And then for the tangent, I have this over this. 1 over 1, it's going to be negative 1. Even if I type it in sine of negative 45, I get that one. Cosine of negative 45, I get that one. Tangent of negative 45, they're the same. We're going to find the exact coordinates of the point P, located in the intersection of the circle with a radius of 5 and the terminal side of 150 degrees and an angle in standard position. Someone already asked, do we need to know this point P? This is where it led into. If I make an angle in standard position, that means it starts here. 315 degrees is in what quadrant? Or sorry, 150 degrees. Second quadrant. Now what it creates is a triangle. Now in the problem it says that it's located in a circle. And its radius is 5. Where does the 5 go? This is your radius. What would we call that in a triangle? Hypotenuse. What's this angle here? Why is it 30? Right. It's the reference angle to 150. Now, we need to find this piece and find this piece. How do I find x? Sine of 30 equals x over 5. So x is really 5 sine of 30. What's the sine of 30? Sine of 30 is a half, so x is 5 halves. To find y, what am I using? Cosine of 30, not bow, 30, equals y over 5. So to find y, it's 5 cosine of 30. What's the cosine of 30? Square root of 3 over 2, so it's 5 square root of 3 over 2. So what would my point be? What goes first in the coordinate plane? X, so it's 5 halves, comma, 5 square root of 3 over 2. Yeah, I made the little mistake of putting these in the wrong spots. I just threw them in, but really to think about it, y is up and down, x is side to side. So the only, right, these coordinates are going to be flipped. This means a y. I didn't even think about it when I wrote it out. Those should have been x's. So these two values should have been flipped. Five square root of 3 over 2, 5 over 2. Thank you. What this really means, to find the coordinates of any point of a circle, If P lies in the intersection of a terminal side of theta in standard position and a circle with a radius of r centered at the origin. It's supposed to say with, but there's a typo. And the coordinates are r cosine of theta, comma, r sine of theta. I don't need to draw the triangle. You should automatically just say, okay, here's your angle, here's my radius. You just put r cosine of theta, comma, r sine of theta. Now, up here I have the unit circle. Units. The unit circle is just for a unit of one radius. So if my radius was 2, what would happen to all these numbers? You multiply every single one of them by 2. This is a shortcut. So if you know the degree, you just look here. What's my first one? Negative a half, which is what value? My cosine or my sine? Cosine. This one is my... This unit circle has degrees and it has radians. So you never have to go and convert. You can just automatically look. It always goes cosine sine because of that.